So let's do the math for the 8 inches times a mile squared and see what angle we get. We just made our measurement. So what we're gonna do is we're gonna take our distance of 52 miles. That's the distance from the point of the observation to Mount Wrightston. So we're gonna take our 52 miles, we're gonna square that, and we're gonna multiply it by 7 times. And we're gonna divide this by 12 to get into feet. So that's the correction. So basically if this were a building or something over there, right? And the building's top angle needed to measure up here, I would need to make a correction for the curvature of the earth that departed from horizontal. Now we need to figure out the difference in elevation so that we can get the angle. So I'm gonna take 94, the elevation for Mount Wrightston, which is 94.56. I'm gonna roll that up, I'm gonna minus it out. Now I'm gonna take the approximate elevation that I'm at, which is 79.87 plus the 5 feet for the height of the instrument. So it's 79.92. So I'm gonna go 7992, minus that out. I have a negative, and that makes sense because I'm looking down at a mountain because of the curvature of the earth. So I'm gonna take this guy and I'm gonna divide it by my run of 274,560. Divide. I'm going to hit the arc tangent of that because I want the angle, and I'm going to turn this into hours, minutes, and seconds. And I get that would be a negative 0.125. So this matches extremely close to the prediction that we would get using the 8 inches times a mile squared to what we just saw in the total station. All right, so I've got a measurement here of negative 1 minute, and it looks like 28 arc seconds. And let's take a look at where Mount Wrightston is measuring. So I'm dead on. Here is my plate level, and here is my circular level. I've also got the wild T2 set up as well, and I have just made coincidence. So I'm going to show you what angle I'm reading here. There's my coincidence bubble. Here is my plate level, and there is my bubble vial. And here is what I'm shooting. And here is the measurement. So you can see the 2 lines up top are made in coincidence. I've got 90 degrees. If you look at the arrow underneath it, that's 0.10 of minutes. And then down at the bottom, let me get you zoomed in a little bit more here. Down at the bottom is let me read that real quick for you. Down at the bottom, we have a 90, 01, 23. We have a 90, 01, 23. So we've got 90 degrees. Zoomed in even more here. There we go. 90 degrees, 01, 23 seconds. Now let's make our flat earth prediction. So we've got our elevation over here of 79.93, 79.93, enter. We're gonna minus that out from our 94.56, 94.56. Roll that up, minus, there's our difference in elevation. We've got a 14.63. So we'll take our 14.63 and we will divide it by our run of the 52 miles. So we'll take our 274,560, we'll divide that, we'll hit the arc tangent, and now we need to get that into decimal degrees, minutes, and seconds. So I need to be shooting for the flat earth, looks like actually we need to minus that from 90, so let's turn it back. So we'll go 90.0000, roll that up, minus, go back. The reason why is because from eye level up is going from 90, 89, 88 up to 0. And so we're minusing from the zenith, right? So we're minusing our shot from the zenith. And so we need to be shooting an 89 24.51. An 89, 24, 51. An 89, 24, 51. So we need an 89, 24, whoops, 51. So an 89, 24, 51. So we're looking up, right? And that makes sense. There we go. All right, let's see where it is. Get this. So it's not there, obviously. This isn't wanting to focus. Come on, focus. There we go. So I'm getting ready to pack up the T2 and the NA2. So I wanted to give you guys a good look. Show you guys that the compensator is indeed, if I can get this lined up. Compensator's working. That is Mount Wrightston appearing below eye level. Although the elevation is about 15 to 1600 feet higher than my location. Globe confirmed.